logistical things to make sure that you are aware of what we need to do and what's going on this week. A friendly reminder that if on that measurement quiz you got a 3, a 2, or a 1, you do need to come visit me. I've got a list of people, and I don't have anybody checked off from this class, so please make sure that you make arrangements to come in to see me, okay? Nobody's talked to me about coming in during Liberty Time today, and I do have a meeting that, like, with people from the district that I need to meet with today during Liberty Time, so that one is off the table at this point, but I am available after school, before school, first and fifth period, or during Liberty Time tomorrow, okay? Please make arrangements to do that by the end of this week. Otherwise, I'm gonna have to hunt you down, might have to send notes home, just like really silly things that I don't wanna have to do. Please take responsibility for your learning, okay? Please take responsibility for your learning. I also want you to be aware that we have a quiz coming up on Friday. It's over standards 1A1 and 1A2. 1A1 is the interpretation of graphs. That's what we've been working on, and we're going to continue to work on today. And 1A2 is solving velocity equals displacement over time problems. Okay, so that will be coming up on Friday as well. Also, just so that I don't get rudely interrupted by the bell, I want you to be aware that you do have homework coming up or for tonight, page 73, numbers 1, 2, and 3. So you might want to just go ahead and write that down right now so you don't forget. Okay, and then once you've done that, we're going to get ready to move on to our graphing motion exercises for the day. Somebody's making noise. Turn it off. Thank you. It's a pleasant noise, at least, I suppose. All right. So today we are going to continue stepping through in terms of drawing graphs and drawing graphs of motion. So the Bucky's Lab and the graphs that you just drew during the warm-up problem are kind of the first stepping stone, okay? You see that there are 3 cases that we're going to look at today. So what I'm going to do is act out the first case for you, okay? And your goal is to write down a description, that means in words, of my motion, and then you're going to draw a graph of my motion, okay? So I want you to look up here because you need to watch me because I'm going to do this. All right, so you need to watch carefully, and then we'll write and draw. Okay, so I'll tell you when I'm going to start and when I'm going to stop. So like when the time starts and stops. All right, so start, stop. Do you want to see that one more time?
Yeah.
Okay. Okay, let's do it one more time. Okay, ready? All right, here we go. Start, stop. Okay, so write down a description of my motion, and then do your best to draw a graph of my motion. I'm going to ask that you spend the first 30 seconds or so quiet, and then I will let you discuss. But I want you to see if you can put something down on paper that represents what you saw, okay? So go ahead and give that a shot by yourself first, and then we'll group together. Show me what you've got, friends. I'd love to see your graphs. Hold them up. Look around. Take a look. What do you see? Nice. Okay, so I see some different things, which is fine because we're learning, right? That's what we're doing together. I'm going to reiterate this all the time, but I want to remind you that this is all about learning, right? So before we draw a graph on here, and I should have said this before, and if I didn't, I can't remember if I did or not, I would encourage you to use a pencil when you're doing the graphs on this piece of paper in case there are mistakes, just so that it's not so messy. That's just me looking out for you. Let's write down a description. Can somebody help me out with what you said here as a description of motion? Nate, do you want to get us started with this one?
You moved forward at a slow pace. Then you paused for a second, and then
Thank you.
Then you increase speed very fast. Move forward.
So I move forward at a slow pace, and then what was the next thing?
Then you paused for a second.
So I can spell. Paused for a second. Not a measured second, but a moment. Yes, And then,
Went forward and sped up and went forward. At a faster speed.
Sped up, forward, at a faster speed. Does that kind of match what you said? If you don't have something written down in that little box, make sure that you do. It can be this or it can be your description with your words, but as long as it kind of matches the story, that's what I care about. All right. I need you to hold your boards up one more time so I can take a peek at them again. I'm looking for commonalities and differences. So there are a lot of commonalities. I see on everybody's board, I think, that we started out with something that looked like this. Yeah? Is that too steep? I mean, to be fair, and I appreciate your concern, because this is a sketch, as long as everything is relatively the right steepness and not steepness, it's okay. But would you like me to make it a little less steep? Would that make your heart a little happier? Like that? Is that?
Yeah.
That's better? Okay, good. I want to make everybody happy. All right. So this part here, what does this correspond to in the description that we wrote down?
Moving slowly.
Moving slowly. Yeah. I'm going to go ahead and highlight that just so I don't get confused here. So that's the moving slowly at a slow pace. Now, I saw on a lot of boards something that I think represents the paused for a second. What was that paused for a second part? Tell me, somebody, what was it? A straight line. I mean, this is a straight line. What's that? Keep talking. A straight horizontal line. You're exactly right. I just wanted to make sure that we were, yeah. Sometimes we use words and we think that's super descriptive, but it's not. It doesn't tell us everything. A horizontal line. Why does a horizontal line represent the paused for a second? What does that? Yeah.
Because we're talking about displacement. So
Okay.
You're not, I guess, displacing anything or going anywhere.
Does that make sense? I appreciate that you said, hey, we're talking about displacement. You know what? We haven't labeled this. I saw that some of you did label it, some of you didn't, but we're going to get best practice here and we're going to label it. We're going to write down displacement. Actually, what I'm going to write down is position, because the graph really represents the position. If you wrote displacement, you don't have to erase it, but that's what I would write there is position. And oh, by the way, if position is on the y-axis, what's on the x-axis? Time. Does that make sense? Yes, we're going to put time down on the x-axis, just so that we're really clear. And then we can see during this horizontal part that as time keeps ticking on, do I change position? No. I don't. I'm just going. I'm just sitting there. Nothing's happening. But time just keeps going. Now, so are we okay with those two pieces? Yep. So that's moving forward and then pausing for a moment for a second. And then it says that I sped up. How do you did this on your warm-up problem, didn't you? Yeah. You had the red buggy and the blue buggy. And you drew two lines. The blue buggy for most of us was slower and the red one was faster. How did you represent the red buggy being faster?
The line was steeper, so
Yeah, you totally stopped talking loud there, but you were exactly right. Yeah, the line is steeper because it's going faster. The line is steeper because it's going faster, so we're going to go ahead and draw that. A steeper line because it's going faster. Yeah? Something like that. And that's the sped up. I'm going at a faster speed. Okay? Is that making sense? You guys did a nice job. I saw this kind of graph on most of you. If you didn't have that, I'm hoping that this makes sense to you now. Yeah? Okay. Are you ready for case B? Oh, yeah. All right. Let's do it. I'm going to pause this for just a sec here because they can't see anything anyway. Yes, I love it. All right, show me your graphs for case B. All right, I love that I'm seeing some labels on axes. That makes me really happy. Yeah, all right. So the labels, hold on, don't put them down yet because I gotta keep kind of looking and seeing what's going on here. Okay, fantastic. All right, so I see so we got position versus time.
Frozen.
It's always frozen. Jeez. And let's go ahead and write down the description again first. What did I do? Who's got this one? What did I do?
You walk.
I walked. Now, if I am going to draw a graph and you just told me that I walked, that's not going to be enough information. So tell me some more information.
Walk at a constant speed.
So I walked at a constant speed. And is that the whole story?
No.
Tell me more of the story then, please.
And then you stop.
Then I stopped. And then what? And then what?
And then you went backwards fast.
Oh, and then I went backwards. Fast. Okay. Thank you. Let me ask a quick question, just to make sure that I am understanding things. Here, you've specified that I'm going backwards. Is that in contrast to what I was doing at the beginning? Yeah? So just to be very clear, because we didn't really specify here, and I'll be honest, Cole, that I probably wouldn't have specified either if it was just the beginning, right? Like, she's walking. Doesn't really matter what direction until something else funny happens, right? So can we add something to this to make it clear, like very clearly different from the backwards?
Forward.
I walked forwards, yeah. So if you were asked to do this on a homework test quiz, some situation like this, maybe I gave you a position versus time graph and asked you to tell me the story, you would want to make sure that you're very clear that, in fact, the object moved forward, blah, 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 backward, blah, 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 so that you know what's going on. All right. So the beginning of the story, I walked forward at a constant speed, moved forward at a constant speed, it was slow, right? How do the beginnings of these two graphs compare? They're the same. So it's pretty easy to do, and I think that most of you had that, if not all of you. And then, so that's the first part. I'm going to kind of color code this again just so we can keep track of what's going on. Then the second part, what did I do? And again, what happens when you stop? What does the graph look like? Flat, right? My position is not changing even though time keeps on ticking away. There it is. I stopped. Now, let me see your graphs one more time so that I can understand what happened next. Because it looks like this is something different than we've seen before, right? Tell me about the line that you have next as compared to all the other lines we've drawn. What you got?
It's a negative slope, but it's still faster. Faster than the first one.
So it's a negative slope. So negative means that it's going down as time goes on, right? But it's also, what did you say? It's steep and steeper than what?
The first slope line.
Okay. Do you guys catch how I'm like asking for more information all the time? It's because I want to make sure that I've got all of the details. So I'm up here at this spot and I'm going to go back down, but I need to go back down steeper because it says that I went faster. Now, there's also one other little piece that Cole's story didn't include, and this is not a criticism because my story would not have included either, but, so let me do this. So I went backwards fast, so backwards fast, so I'm going to make a couple notes here, and you might want to make these notes as well, that this is a negative slope because I moved backwards, and it's a steeper slope because I moved what? Faster. I may even want to make a note. I'm going to make a note on case A, right? That this one has a steeper slope. Steeper slope because I'm moving faster. Just because it's nice to have all this stuff written in one spot so that you know what to do and you can kind of interpret it and understand how to put it all together. Okay? Where did I stop? Did y'all notice? You guys were in the kind of the front. Could you tell?
Oh,
Yeah, exactly.
finish line.
At the finish line, which was also the start line? Yeah, so talk to me about my position. Let's think about this literally what was happening. So I was here, I was at the starting line at the blue tape. And for those of you guys that are kind of in the back, you have to just trust my friends in the front here that we were doing what we could, right? So I moved this way, I was moving away from the starting line. So this is like the starting line. I moved away, then I paused, and then I came back, and I came back to the finish line. So I see that some of the graphs that I'm watching go like this. What would that mean? I mean, I went that way, right? Yeah. Does that make sense? So in this particular case, I didn't do that, or at least I didn't intend to. I tried to stop right on the line. I may not have, and sometimes that, I did a few times, who knows? But that's what I was going for. Okay? How are we doing right now? Okay. Now, before we move on to case C, you may have noticed on this graphing or on this piece of green paper that not only are there, 3 graphs across for cases A, B, and C, and I was going to label this little box right over here, position versus time graphs. But there are actually 3 other graphs or 3 other axes that are included on this piece of paper. And the reason for that is because we can make other graphs that also describe the motion. Yeah. The graphs that we're going to put down here are velocity versus time graphs. Okay. So the velocity versus time graph can be built, can be drawn from the position versus time graph. I'm going to help you with the first one. Okay? And the reason that I said you might want to have a ruler out is because sometimes it's nice. Again, we are sketching, so it doesn't have to be perfect, but sometimes it's nice to kind of keep track of about where the times are so that you can kind of keep your times in line. So if you would like right now, you are welcome to. You do not have to. It's not required. But it might be helpful to just draw straight lines down from your position versus time graph. I'm going to see if this was acting really goofy before, so we'll see if I can get it to work here. Is that drawing a line? Yeah, like that. Just so you can kind of line them up. Does that make sense? Again, you don't have to do this, but it just might be easier to see it so you could line them up. Just so that these times kind of match up with these times up here. Okay. And again, we can refer to our story. If you don't remember what I did, the first part of the story is that I moved forward at a slow pace. During this yellow section here, did I have a velocity? Was I moving? Yeah? Let's remember what velocity means. Let's remember that velocity is change in position. Oops, change in position, sorry. Got ahead of myself there. Over time. Was I changing position as time went on?
Yes.
Sure. Is my velocity positive? Yeah. So I'm going to draw a positive velocity because I was moving. I was moving with a positive speed. So here we go. I'm going to draw this like this. And I'm just going to kind of arbitrarily pick a spot and draw it like that. So I'm going to push this up a little bit so you can see. Okay? I was moving away. I have a positive velocity. So I have a positive velocity. Bless you. What happened during this green section, friends? Do you remember?
You stopped.
I stopped. If I stopped, tell me about my change in position over that time. It's 0. What was my slope during that time? It was 0. What is my velocity during that time?
0.
Oh, look at us learning. I love it. Yes. We have zero velocity. Okay. Zero slope. Zero velocity. All right. So I was moving with some velocity. That's my yellow piece. And then I stopped. That's the green piece. And then what happened in this blue piece?
You went faster.
I went faster. If I went faster, what does that mean about my velocity?
Higher.
It's higher. Can you do that? Can you draw that over on this one? Yeah, it's just going to be a line like this, right? A constant line, because I was moving at a constant speed, but it was a higher speed, so it's going to be up something like this. And again, I don't really care about the numbers. The only thing that I really am picky about is that if this slope is smaller than this one, that this value is smaller than this one. Okay? This is what I'd like you to do right now. I would like for you to work with your table to figure out how to draw the velocity versus time graph for case B. Okay? You can go ahead and talk. I'm not going to give you you need to be silent for a minute. Okay? Go ahead and have a conversation. If you want to draw lines down like we did on case A, you're very welcome to do that. Okay? Go ahead and give that a shot. All right? We'll regroup in just a minute.
Because you went faster.
All right, friends. Looking for a velocity versus time graph for case B. Go ahead and put your graphs up so I can see them. Go ahead and put your graphs up so that I can see them. All right. Okay, you can put them down. We're going to talk for just a second to make sure we're good. So how does the yellow part compare to the yellow part from case A? Same, right? Like it's the same story, same thing is happening. So we're probably going to have the same kind of graph, I'm thinking here, right? So it's going to be somewhere up here. Yeah. We've got a positive constant slope. So we've got a positive constant value. I'm going to write that down, and I would strongly encourage you to as well. We have I'm going to write this in green though. A positive constant slope. And here we have a positive, so you should be writing this down too. Yeah, constant value. No, not on your whiteboard, because you're going to erase your whiteboard in just a minute, right? The green sheet is kind of your ticket to understanding, whereas the whiteboard is just a communication tool for you and me. Yeah. Okay. How about the green? How does the green one compare from A to B? Same.
But
It's not in this one. It's not. I appreciate the reference. I'm gonna get that book so I can read it to you sometime. It'd be great. What's a little
so
story
much
time.
moving in class.
No. Zero slope, zero velocity. Yeah? Okay. So there we go. Bam. All right. Last piece. Is the last piece of case A the same as the last piece of case B? Did you say yes or no?
It's a little bit.
It's a little different. How is it a little different? It's going down. Remember in this one, I kept going away further and further away. So my change in position was positive, wasn't it? In this second one, is my change in position positive or negative in case B?
Negative.
It's negative. If my change in position is negative, what does that mean about my velocity? If I have a negative change in position,
It has to be negative.
it's going to be a negative velocity. Right here, we represented that by a negative slope. That means that this value here for velocity needs to be what?
Negative.
It needs to be negative. Yeah. So we're going to have a positive velocity at the beginning. then 0, and then negative. And it is more negative than this one was positive because this one is steeper. Okay? So it's going to be somewhere down here. All right. Velocity. Remember we said was speed with direction? We said that a bunch of days ago. Okay? The direction in this case is positive and negative. So velocity can be positive or negative. And in this case, because I'm going backwards, I've got a negative velocity. Sam, you seem a little concerned about that, though. Can you talk to me?
You said like velocity could be negative.
Because change in position can be negative. Does that make sense? So if I go backwards, so can I like literally? Bell's gonna ring in just a sec, I think. But literally, let me explain this to you just real quick, right? If I have change in or position final minus position initial, and my final position is 3 and my initial position is 7, then my change in position is negative 4. Does that help a little bit? We'll process with it tomorrow too, okay? Friends, I want to remind you again that you do have homework for tomorrow, okay? Please make sure the whiteboards, rulers, markers, everything get put away before you go, okay?
Do we need this bottom part for anything?
We will soon, we just don't need it yet. Don't lose your green sheet.